we're starting on the final review. Finals are going to start next week. We're starting at number 65. You can use a full sheet of paper as a cheat sheet, front and back. You cannot share a cheat sheet, and they get taken up from you after the period. So you can't give it to anyone in a different class. So make sure that you have time to make your own cheat sheet. Everything I write down on these, on the reviews, is a good idea to probably get them down on your cheat sheet. So yield means to make and synthesize. It says what volume is required to make 0.250 moles of a 2 molar solution. So what volume? We're looking for V. The way that you use this triangle, whatever you do not have, you kind of put your finger over. So it's moles over molarity to figure this out. It says the moles was 0.250 and molarity was 2. So you just put that in your calculator and answer it. I'm going to move on to number 66. It looks like I answered this one already. It says, what is the formula for dilution? It's M1V1 equals M2V2. M is the concentration. The initial concentration is M1. V1 is the initial volume. M2 is your final concentration. V2 is your final volume. Number 67, we have to use this formula. What's the concentration? So we're looking for M. Okay, we don't know what that is. Made by diluting 25 milliliters of 6.00 molarity to 500. So this is what we started with. And this is going to be V2. Okay, so you'll plug everything in. You're going to multiply these two numbers first. You'll be able to do the rest on your own. If you don't know how to do the rest, you probably need to come see me. During lunchtime is the best time to come for tutoring for me. If lunch never works for you, there's a tutor calendar on the red board over there, and there's also in the classroom. There's lots of different teachers to work with you. Okay, number 68, what volume? So we don't know. We're looking for the volume. Is needed to make this much from the original solution concentration of this. So this is your M1, because that's the original concentration. And this is going to be our V2, M2. This is what we want to end up with. Okay, so you set it up. And you would multiply 12, or start on this side. Multiply 250 times 3 first. You'll get a number, and you're going to have to divide on both sides to separate these two. Number 69. You have to look at the picture really close. I'm going to fold this in half. Okay, so you're looking at the picture. It says, according to the picture on the right, HCl is a strong acid or a base. So you're looking at what it breaks into. I have to take a closer look. So it breaks into H's. So if it's breaking up into H's in this diagram right here, it means it's a strong acid. Arrhenius acid, the solution breaks up into H's. Acids do. H or H3O. Okay, those two are interchangeable. An Arrhenius base breaks up into OHs. Bronson-Lowry acid, Bronson-Lowry base. Okay, do you guys remember this is the ones that say acceptor or donators? So which one donates? Bases accept. flip the page. Or I need to flip mine. You can have a diagram, this one up here. You're just going to have to pull information from it. Label each of the following solutions by circling the proper description below. Let's look at solution 1. So it can conduct electricity. So number 1 is an electrolyte. You can just look at the pH numbers probably when you see this on the exam, because you will see this on the exam, and it'll tell you if it's an acid or a base. Okay, so the scale starts at 0, 7, 14. If it's close to 0, strong acid. It's close to 14, strong base. Now, if it's still below 7, but it's close to 7, this is a weak acid. Now, 7 is neutral. If it's somewhere around here, it's considered a weak base, like 7.1. You want to know this chart for your exam if you don't know it. So solution 1 is a 10. It's going to be up here, so I would consider it a strong base. Solution 2 is a 6.5. So it's still on the acid side, but it's a weak acid because it's near base. So weak acid. Solution 3, it's a 5.4, which is pretty acidic. It's kind of middle. I'm going to go with weak acid. Just know it's an acid. If you put it as strong, that's fine. Solution 4 is 2.0. And I'm just looking at the pH. A 2 is pretty strong. That's a strong acid. The low numbers, again, are acids. Let's go ahead and look at number 72. In the table to the right, if sample Z is less acidic than sample X, so it's less acidic, it's not more acidic, so the number's getting bigger. Less acidic than sample X, so it has to be a bigger number than X, but more acidic than sample Y, so smaller than Y. What conclusion can you say about Z? Okay, so bigger than X. X is 3.3. Smaller than Y, so it has to be less than 5.2. And greater. Okay, so it has to just fall between 3.3 and 5.2. So my conclusion, that's my conclusion. Greater than 3.3, less than 5.2. I could guess it could be 4.0. Okay, but it's not asking you to guess. So you'll probably see a problem like that. Number 73. If you need to see the side, I don't think I was recording when I wrote it down. H3O and H are the same thing. If you need to write that down on your cheat sheet. It says calculate the hydronium and hydroxide concentration. So find H and OH. If it says 1 times 10 to the negative 10 is your H concentration. Okay, because HCl is H concentration. So these two are out because this says H3O is 1 times 10 to the negative 2. The H3O has to be this. This one says it's 1 times 10 to the negative 5. So it's really between A and B, and then the formula is written for you right here. This is the original formula that you guys probably have. I just plugged in what I had and did not have, and you'll have to rearrange some things. So I'll give you a second to write this down if you haven't written it down yet. And then you'll have to do the calculation. Number 74, increasing the volume. So increasing volume, you're making something bigger, okay? Increasing the volume, let's say that it started off, you know, that big, and now you made it that big. And the container is filled with gas. If it says it's at constant temperature, that just means temperature is not included in this formula. So fill at a constant temperature causes the pressure to decrease. So it was this little, and then it got bigger. So yeah, there's less pressure. Because when you have more space for the molecules to bounce around, they're gonna move a little slower. If it's a really tight area, then it's high pressure. So pressure decreases because, did the mass decrease? No. Potential energy increase? Maybe. The molecules are moving faster. The molecules are not moving faster. A, the molecules are striking a larger area with the same force. Yeah, A. Okay, it just got bigger. The volume increased, the size increased. Number 75, how many grams of oxygen gas are contained in 10 liter at 25 degrees Celsius, 2.5 pressure? Okay, so we're going to have to, let's see, so do we have P? We have P, do we have V? We have volume. N is the number of moles, so that's what we're figuring out. We have to find moles and go to moles to gram. And then R we have, because it's on the periodic table, temperature's right here. On your periodic table, what is the constant for R? If you could look on the back of your periodic table, it says R equals... So you'll need to find this, or you can write it down now on your cheat sheet. It says R right here. R equals 0.0821. So to figure this out, it's 2.50 times 10 equals X. R we just said was, R is a constant and it's never going to change. 0.0821. And the temperature is 25 Celsius, but change that to Kelvin. Okay, so you just have to solve that. Multiply these, and then you're gonna have to divide some. Okay, I'm gonna go to the next, and then after that, this gives you moles. X equals moles. Convert moles to grams. And all you'd have to do for that is, wait. We want grams. Grams of O2, and it tells you that it's 32. That's from the periodic table. Moles. So you'd set it up like that. Because we're figuring out moles, but we need to go to grams. Moles to grams. Let's go to 76. We're going to stop here and leave the rest for tomorrow. I'm going to go ahead, because we have the rest of the week, I'm going to require that everyone in the class makes a cheat sheet. Make a cheat sheet. There's computer paper on the very front table. It's going to be a grade. Use the time that we have in class.